Hello, Mr. Schlesser from the Quantitative Reasoning Center. Question: how do you get good at juggling? Simple. Practice. And anyone can do it. Question: how do you get good at math? Same answer. Practice. And, once again, anyone can do it. Here's one to practice on now. Let's look at this one, number 109 from section 7.1. In this problem, we are given a function, which is a rate at which oil is leaking out of a tank. Now, you'll notice my function looks a little different than yours. Don't worry, all the principles are all the same. It's just a matter of the numbers are a little different, so you get a chance to practice on your own. Okay, this function, this rate at which oil is leaking out of a tank, the units are 1,000 liters per minute. In part A, we are asked to find what rate the oil is leaking out when t equals 0. Also when t equals 60. For a little board management, I'm going to go ahead and work part A over here. Okay, so we're looking for when t equals 0. What's the rate? Quite simple, we'll just throw it into our equation. We're looking for r of 0, the rate when t equals 0. And that's going to be 40 e to the negative 0.030. And simple algebra there, we know e raised to a 0 power is 1, so our answer is 40. And remember our units, thousands of liters per minute. So let's make that thousands of liters per minute. Okay, second part, we're asked to find the rate when t equals 60. That'll be 60 minutes later, or 1 hour. So we're looking for r of 60. To do this, again, plug it into our equation. 0.03 times 60, and that is a simple honor later problem. You can throw that in your calculator and you will see that it equals 6.61, and once again that's thousands of liters per minute. So let's just go ahead and make that thousands of liters per minute. Okay, so now I know that when t equals 0 minutes, I'm leaking oil at 40,000 liters per minute, and when t is 60, 1 hour later, I'm leaking oil at 6,600 and some change liters per minute. Okay, that sounds fair enough. Okay, for part B, we are asked to find the total amount of oil, the amount of liters of oil that have leaked out of the tank over the first hour. Now recall that our units for time is minutes, so we're going to need to take our function, which gives us the rate of liters, 1,000 liters per minute. We're going to have to integrate that between 0 and 60 minutes to give us the total amount of oil that is leaked out during the first hour. Okay, so how do we do that? Simple, 0 to 60, our function, 40 e to the negative 0.003t. And of course I'm going to need a dt in there to do a proper integral. Okay, so now let's look at this here. One of the first things I can do is I can get rid of that 40 in there, because we know we can pull a constant out of an integral with no problem. So I'm left with 40, 0 to 60, e to the negative 0.03t dt. Okay, now I have e to something, but it's not a good something. If it were a nice plain variable, I could take the integral. I know the integral of e to a variable is just e to the variable. Unfortunately, this one's a little more complicated than that because it's got this out in front of the variable. So to do that, we're going to have to basically undo the chain rule. And in this case, to undo the chain rule, we're going to use a technique called integration by substitution, or a W substitution. So I'm going to have to define, it would be really nice if this were just one variable. So let's go ahead and just call that a variable. Let's call it W. So we can say that W is equal to this right here, negative 0.03 t. And I'm going to know the derivative. The derivative of W with respect to time is negative 0.03. Okay, so dW dt, we know that is technically just one unit. That is the derivative of W with respect to time. However, if you grant me a little license here, I'm going to split that thing up so that we can substitute back into our function over here, okay? So just go with me on this, all right? So I'm going to multiply both sides by dt. It's going to give me negative 0.03 dt. And now I'm going to divide both sides by negative 0.03. So I can isolate dt. Negative 0.03. And let's just multiply this by negative 0.03. Okay, those cancel. So now I know that dt is equal to 1 over negative 0.03 dW. Okay, this is important. I'm going to need to know these two quantities right here. Okay, so let's do one more thing just for clarification's sake. We set this integral up from 0 to 60. It's important to note one thing. These limits of integration were based off of t, our time, going from 0 to 60 minutes. So let's just put a t equals 0 to t equals 60. Okay, so now let's substitute this information back into here, and I think we're going to get a nice simple little integral that we can handle easily. So I've got 40 integral e to the this, which we defined as w, that's nice, okay, times dt. Okay, what's dt? It's right there. It's a negative 1 over 0.03 dW. Okay, hopefully not getting too big of a mess here on the board. Let me go ahead and make some space. Get rid of this. Alright, so now I've got an integral. However, what are those limits of integration? If you recall, they were t's before, but now I've got some w's in there that I'm defining things off of. So in order to convert those, I'm going to have to know how t and w are related. Fortunately, we've got this right here. So if my w is going to equal 0, I'm going to put in 0 and 60 here. Put in a 0, I can see that my w is still 0. So that one's good. I can still have a 0 down there, and now it's w equals 0. Okay, what about for this 60 up here? We have w equals negative 0.0360. And do the math here, that equals negative 1.8. Okay, so now I know my upper limit of integration equals negative 1.8. Okay, now I've got something I can work with. So let's go ahead, and here's another constant that I can pull out to the front of that integral sign. And I'm going to make a little more room here. I think we're pretty much done with this stuff. So now I have 40 divided by negative 0.03 integral. Remember, these are w equals 0 and w equals negative 1.8 of e to the w dw. Now that I can handle. That's something that I know how to do. So, integral of e to the w, quite simple. E to the w. So, I've got negative, do the math here, is equal to that. Take this integral, it is e to the w. I like that. And I'm going to evaluate this integral between 0 and negative 1.8. Okay, recall the fundamental theorem of calculus, and let's just go ahead and do this. We've got negative 1333 times e to the negative 1.8 minus e to the 0. Boom. Not hard. Simple algebra. You can do that. And you do that and you will come up with approximately, recall that our units they're still liters, thousands of liters actually, and I came up with 1,112,660 liters. Okay, so now you get to work the same problem using slightly different numbers and a slightly different equation. But I think you can do it, and the practice is good for you. Take care.